In this problem, we're gonna prove the following. We're gonna let a be a real number, and we're gonna assume something that a is strictly positive. We wanna prove that 1 over a is strictly positive. Okay, so in this case, we don't want to use the axioms. Okay, we can give a simple proof of this result. Okay, we can use the fact that if a is different from 0, it always has an inverse. Okay, that means in R, okay, for every a in R star, that means this is R minus 0. Okay, there is an a inverse such a times a is 1. Okay, we can always find 1, and this a inverse is simply 1 over a. Okay, and also we can use the fact that the product of two numbers, if it is positive, that means these two numbers, they have the same sign. They can either be positive or both of them negative. Okay, so we can use that fact as well, and that means that if a and b are the product of a, b is bigger than 0, then either a is bigger than 0, b bigger than 0, or a is less than 0 and b less than 0. So we have only these two cases. Okay, we can use that fact here. Okay, we can use that here and prove this result. But we're going to use something else that's very nice and very quick. So we're going to prove this one by contradiction. Okay, so we're going to assume that a is bigger than 0, but 1 over a is less than 0. We're not going to put the equal sign because a cannot be 0. Okay, so if a is bigger than 0, then 1 over a is less than 0. Is this true? We assume that we have this, but we have this result here. Okay, so using the ordering in R, we can multiply. So since a is positive, we can multiply by a. Nothing is going to change. So we're going to have a over a is less than 0 times a. We know that this is 0, and this is just 1. That means 1 is less than 0. This is a contradiction. Okay, therefore, if a is bigger than 0, then 1 over a is bigger than 0. Okay. Okay, that's the case for us. Okay.